And hello everyone, Radical of Math here. Let's do some math together. It's been a minute. And the equation on the board, and I just want to ask a question. And the question is, how many rational roots? And then I'm going to ask the follow-on question, how many integer roots? So, in a proper Algebra 2 class, this is a problem that you should end up seeing. And the thing that I want you to realize is going to be that by the rational root theorem, this has a very specific result. So I'm going to give you a moment to think about that as I get my eraser. And then while you're at it, view this from the integer roots perspective. And let's see if we can answer that question as well. So, for rational roots, there's something called the rational root theorem. And what that theorem says is that for every sign change, there's a rational root. The issue is all these are positives. So automatically I know that there are no fractions as a solution. So what do I mean by that? If the solution was this, then my term would have a leading coefficient in front of the variable. So I already know there's no fractions in the rational root theorem. So now I got to look at integers. So my next clue is that everything's positive. So I already know if I do 0, 3 is not 0. So that means any integer roots are less than 0. It's a negative number. So obviously -1 is the one I'm going to start with. And as we find out, this is a root. So -1 is a root. That means x plus 1 is a factor. Now, the issue you're going to have is now you got to break this down into a cubic. You need to learn synthetic division. So let's do some synthetic division. So there's the synthetic division. If you do not know synthetic division, make sure you learn it. And if you're not learning that in Algebra 2, shame on your teacher. This is the fastest way to factor this big polynomial. But what do these numbers mean? They are your coefficients. So you drop one coefficient. This is your x cubed term. That's your x term, and this is your constant. We have no x squared here, it's 0. So let's rewrite this. Let's rewrite it. So we know x plus 1 is a term, and so now I have x cubed plus 6x plus 3 is a factor. And the other factor, we're just going to move it on over, make it nice and neat, is 0. So we know this exists. So now we need to look at this. So once again, let's isolate this. Same property. When x is greater than 0 or 0, it will be greater than 0. So once again, we know it's a negative number. So, you have no rational roots. Same concept. So you now know once you get a minus over here, you're done. So if I do -1, -4 is less than 0, but we already know 0 here is greater. 0 plus 3 is greater. So we know there's a root. So we know x has to be in that range. And we know x cannot be a fraction. Plus, plus. And so now you're done. So, how many? That was the question. The answer is no rationals. And you have one integer solution. This problem was found on X, and I felt it was a pretty simple problem. If you know algebra. So I hope you like this. Looking forward to publishing more math content on the channel. It's good to be back, and I hope to see you soon.